All right, we're back. We are on page 84 of math analysis, so we're kind of moving along. And what we're going to do now is we're going to keep solving trig equations. But if you think about it, all the trig equations that we've solved so far have been like for all reals, right? Like find every possible answer. So what we're going to do now is kind of like switch it up a little bit. And instead of finding for every possible answer, we want them on a very fixed domain. So what we're going to be finding are something called particular solutions, not general solutions, particular solutions. So let's see the difference between them. So for example, if you were asked to solve this, I think you can solve this pretty much by thinking. So I'm going to say that x would be 5 pi over 6 plus 2 pi n, or x could be 7 pi over 6 plus 2 pi n, and then n has to be an element of the integers. All right, now let's look at almost the same problem, but a little bit different. So now all we're interested in are the solutions to this. So the solutions all look like this. This is every possible solution. Either this, or, and maybe we should write that as 12 pi over n just to like simplify our lives. We're either going to do this, or we're going to do 7 pi over 6 plus 2 pi n. What if we only want our answers between 0 and 4 pi though? Well, all right. So now let's think about it. So first, we could get 7 pi over 6. That's the first place that this happens. Is it? No, 5 pi over 6 is the first place this happens. The heck, man. All right, 5 pi over 6. First place it ever happens. The next place it ever happens, 7 pi over 6. Those are between 0 and 2 pi. So these are between 0, I don't know, less than 2 pi, let's say. Right, so they're in your first revolution. Now, if I just add 2 pi to the first one, I get another angle that's coterminal, so it definitely works. So if I add 2 pi, that's going to take me to 17 pi over 6. And then if I do it again to this, it's going to give me, what is that, 19 pi over 6? So these answers that we just found are less than 4 pi because they're in 2 revolutions. So these are all your answers. So if you were asked to solve this between 0 and 4 pi, you would say only these answers. Because if you go again, right, if we try to add 12 to 17, you get 29, but 29 pi over 6 is bigger than, there's a little thing you can do. So since it's over 6, let's rewrite this as 24 pi over 6. So you know that you're going to stop when you get to 24 pi over 6. If I add 12 to 17, I get bigger than that, so I know that I'm done. So these are particular solutions. They're not general solutions. There's no like plus n plus anything. It's just write down the exact solution. So this is a specific domain. These are, I never really have decided exactly like how I like to solve these. But we're finding particular solutions. So that terminology is going to follow you for a really long time. Let's see if we can solve this. Nobody wants to solve this problem. So let's instead solve, what's the reciprocal of this? Negative root 2 over 2. All right, now I have a really good idea. So I know that these are going to be pi over 4 angles. Since they're pi over 4 angles, I'm going to change this to 32 pi over 4, which is 8 pi, right? So what I can do is, let's just see between 0 and 2 pi. So like in the first revolution, where does this happen? So x could be negative, so 5 pi over 4, or it could be 7 pi over 4. All right, so this is less than 2 pi. So now what I'll do is I'm going to add, so 2 pi is 8 pi over 4. I'm going to add that to here and here, and it'll give me, maybe I'll just stick with that color so I don't have to switch up a million times. So 13 pi over 4, and then 15 pi over 4. So these are less than 4 pi, like one more revolution. So now what we're going to do is from here, I'm going to do it, and from here, I'm going to do it. So 21 pi over over 4 and 23 pi over 4. So these are less than 6 pi. And they're bigger than 4 pi, but like there's no reason to write that. Well, I guess everything to the left of 23 pi over 4 is less than 6 pi, so it still works. And then I need one more color because I got to go to 8 pi. So here and here. So we're going to get 29 pi. And then if I do it again, I get 31 pi. And if I try to go again, so these are less than 8 pi. If I try to go again, I'll be bigger than 8 pi because I've done every possible revolution. So these are our answers. We got them in a nice, neat, organized way. Find them in the first revolution, and then just keep adding the period until you hit the upper bound. It's really not that bad. I kind of enjoy doing it. Now, the next problem, I'm going to stop the video here, but the next problem, we got to basically do like a u-substitution as we do it. So they get a little more complicated, but if you understand the basics, you're going to be fine. So I'm really going to do u-substitution on the next one, and I hope you follow along. So I'll see you there.